So we're making a bike wheel of radius 5 that's traveling along the x-axis, and we're going to be tracing the path of the light attached to the wheel. So I obviously taught a lesson about this, but I want to kind of re-explain the reasoning behind some of these pieces to try to help you understand it further. So the first thing we should try to do is just come up with the circle that is positioned in the right place to model the bike wheel. So it's a radius of 5, and we know that the point needs to be traveling clockwise, which means sine needs to come first. So we're going to start by letting x equal 5 sine t. And then let y equal 5 cosine t. So this is a circle of radius 5, but currently it's positioned at the origin. So we don't want it at the origin, we want it resting on the x-axis. So if we want it resting on the x-axis but still starting at the origin, all we need to do is shift it up, right? We're going to shift this thing up. So what do we need to affect then? If we're going to shift upwards, do we affect x or y? Well, y are our vertical values, so we're going to add 5 to our y value. And now you should have, when you type this into Desmos, you should have a circle that is resting on that axis. And how you type it into Desmos is like this: 5 sine t, comma 5 cosine t plus 5. Okay, and then obviously we go 0, t, and then you can let t value become big. Let's let it go to like, well, for now it's fine. We'll make it 2 pi. Okay, cool. So now the problem is, well, so the issue is now that when we plug in t equals 0, x of 0, we're going to get 0 because sine of 0 is 0. And if we do y of 0, we get 5 cosine 0 plus 5, which is equal to 10. So when we draw our wheel, our light is starting up here at 0, 10, which is fine, except for the fact that the problem says that we're assuming the bike light starts on the ground. So what we have to do then to adjust this is we just have to throw a negative sign out in front of our trig functions here. And that's going to reflect this point down so that it now starts down here. So this is our wheel. This is our wheel. And now the thing is, if we want our wheel to actually roll, we need to allow our x value to get bigger. So we need to attach some kind of slider to our x value. So what we're going to do, let's come over here now. So this is our wheel, this is our bike wheel, but we want it to move now. So what we're going to do is we're going to make this x equals 5b, because it's a radius of 5b minus 5 sine t, and y is going to be just still negative 5 cosine t. So then b is going to be a slider, so that when you start, and you can start b at 0, so let b go from like 0 to 100. So start b, let's go from 0 to 100. Now when you hit play, you should have a circle that is moving along the axis. But our last step to really kind of model the motion of a point on that wheel traveling around the wheel, we now actually have to figure out where the light on the bike is going to be at any given time. So the thing about this is that the t value here is not changing when b goes up. It's just causing this circle to move along the x-axis because the x value is getting bigger. But how we can actually model the point is we're just going to replace t with this slider b so that the actual xy point is also changing as b changes. So all we have to do for the actual light, is copy all this down, but just replace t with that slider b. So what you're going to type in is 5b minus 5 sine b, comma, and then put this in parentheses too, 5 minus 5 cosine b. Close your parentheses, close your parentheses. Okay? So now if you have this typed into one cell and you have this typed into another cell and you hit play on B, the circle should move and the light should also model the path of the point on the circle as this wheel is moving. So now you have this path modeled. And finally, to actually show the cycloid on your Desmos graph, okay, now you're going to not have a slider because you want this to just be a single curve, and you're just going to type in 5t minus 5 sine t, comma, 5 minus 5 cosine t, close parentheses. And that's going to give you this graph that looks like a cycloid, which models where the actual light is at any given moment as the bike moves.